Welcome back. This is lesson 2.10 journal. We are problem solving with fractions and mixed numbers. I will be able to correctly solve real life problems, situations involving fractions and mixed numbers. I will also be able to show a clear plan based on clues from the context, meaning from the story, and answer the question correctly. Our vocabulary for this lesson, we have fraction, which is part of a whole, numerator, which is the top number on the fraction, denominator, the bottom number of the fraction, equivalent fractions, meaning that they share the same value but they have different numerators and denominators. Reciprocal, the flipped fraction. Mixed number is a whole number with a fraction. Improper fraction means that the top is bigger than the bottom. And factors are numbers that multiply to create another number. Most students struggle with formulating a correct plan when solving story problems. This little graphic organizer will help you identify the parts you already know so you can know how to approach the problem. Fact family types that we deal with. We have your add and subtract family and your multiply divide families. So in each one there is a total. So I want you to write total here. Okay, the difference is here. There's the first item and the second one. Together, they make the total. So, if you know the first, you know the second, you add it together to get a total. If you know the total, but you know the second part, then you know that you're minusing. Or if you know the first part and the total, you know you have to minus to find the second part. So that's how they're all interrelated. Okay, our big focus though, most of you can figure out adding and subtracting pretty easy. I see a lot of problems when we come to multiply and divide problems. So there are two factors, but they're two different kinds of factors. So we have the number of groups, so that's one of the factors. The other one is the size of each group. So, if you know the number of groups and the total, you're going to divide the total by the number of groups to figure out the size of each group. If you know how many groups and you know the size of each group, then you're going to multiply that to find out the total. So, when you're reading a story problem, I want you to pick out what you know about it. If you use this little triangle organizer, it can help you make sure that you're not messing up the problem. Okay, these two problems, we're going to use both of these. You just have to think about what's happening. So we're going to make a plan by listing out what happened in order, or how we could do this in order. Okay, Eli buys 9/10 pounds of candy. He eats 1/3 of the candy on his field trip. After that, he splits the remaining candy into 4 bags. How many pounds of candy are in each bag? Alright, so we always start with first. So first, what did he have? First, he has 9/10 pounds of candy. Alright. Then, so in the story, then what happened? Then he eats 1/3 of is a timesing word. So 1/3 is the number of groups. It's just a portion. So 1/3 of what? The group he had was 9/10 pounds of candy. So after we do that, I'm not doing any math yet, I'm just setting up my problem. So he eats 1/3 of the candy on his field trip. After that, he splits the remaining candy into 4 bags. So remaining candy is what, so this would be what he eats. He eats 1/3 of the bag. So I'm just going to write eaten here. So the eaten candy if I find out how much he's eaten, then what am I going to do with it? I'm going to have to minus it from how much candy he had. So I'm going to do 9/10 minus, I don't know yet, but how much he has eaten. And that's going to give me the remaining candy. See how all I'm doing is making a plan based on what happened here? 1/3 of it to figure out how much he ate. Then we're going to minus how much he's eaten to figure out the remaining candy. So after that, he splits the remaining candy into 4 bags. What is he doing if mathematically if he's splitting the candy into 4 bags? So then the remaining candy is getting divided into 4 groups. After that, how many pounds of candy are in each bag? That would tell me what my final answer is. So I should have an answer by the time I get to here. Okay, now I have a plan. Let's follow through with our math. So let's first figure out how much he's eaten. So 1/3 times 9/10. I can cross cancel and simplify these factors. So 3 goes into 3 one time, 3 goes into 9 3 times. I don't see anything else top or bottom I can cross cancel. So 1 times 3 is 3, and 1 times 10 is 10. So he ate 3/10 pounds of candy. So the remaining candy he splits into 4 bags. So to figure that out, I'm going to minus it from how much he had. So 9/10 minus how much he ate, which was 3/10. We already have a common denominator, so I can just minus across the top. So 9 minus 3 gives me 6. So 6/10 pounds of candy are left. Okay, so the remaining candy, now I'm going to divide that by 4. So we have 6/10 pounds of candy. We're going to divide that into 4 groups. Now since I have fractions and I'm dividing, I'm going to keep the first, 6/10, flip the second, 1/4, change the sign, cross cancel if I can. 1 and 10 share nothing in common, but 6 and 4 do. 2 goes into 6 3 times, 2 goes into 4 2 times. Nothing else top or bottom. So I'm going to multiply across the top. So 3 times 1 is 3. 10 times 2 is 20. That fraction will not reduce at all. So our final answer is he put 3/20 pounds of candy in each bag. Okay, you can see how my plan helped me for solving. If I know what I'm going to do, then it's a lot easier for me to do it instead of just trying to decide what I'm doing at that moment in time. So that's why I made a plan. Let's make a plan for this next one. Vanessa has 2 3/8 cups of sugar. She uses 1/4 cup each time she makes a loaf of bread. She's going to make 1 batch of muffins that take 5/8 cups of sugar. How many loaves of bread can she make if she also makes 1 batch of muffins? So with that, we know how much she has at first. She first has 2 3/8 cups of sugar. Well, if she wants to make 1 loaf of muffins, or 1 batch of muffins, she's going to need 5/8 cups of sugar. So she's only making 1 of those, so it would make sense for me to take out how much sugar she is using for the muffins. So then let's do the muffins. So it'd be 2 3/8. And then I'm going to minus out how much for the muffins. So that would be the sugar left over after the muffins. I'm just going to call it sugar left. Okay, what am I going to do with the sugar left? Well, if I want to know how many loaves of bread she can make, I'm assuming she wants to use up all of the sugar left. So she uses 1/4 cup each time she makes a loaf of bread. So the sugar left would be the total amount of sugar. This would be the size of each group because each loaf would be a group. So thinking about this up here, I have a total, the sugar left, and I have the size of each group. Each loaf of bread takes 1/4 cup of sugar. So the number of groups is the number of loaves, and that's what we're looking for, is how many loaves of bread she can make. So then I'm going to take the sugar left, and I'm going to divide it into groups of 1/4, and that will tell me the number of loaves. So that will get me to what I'm trying to answer, so that will give me my final answer. Alright, now we're going to go ahead and do the math. So first take out the sugar that she'd need for the muffins. Okay, remember how I talked about mixed numbers being only good for final answers? So here I'm going to turn this improper to make it easier on ourselves. So it would be 19. So 19 over 8 minus 5/8. Now, since these are fractions and I'm minusing, I need a common denominator. But thankfully we have a common denominator, so we don't have to worry about that. So 19 minus 5 gives me 14 over 8. Now, I would turn this into a mixed number if this was my final answer, but I'm not done, so I'm going to leave it improper for now because it will be easier for me to work with here. So the sugar left was 14/8. So I'm going to say 14/8, and then I'm going to divide that by 1/4. I'm following my plan here. Okay, keep the first, 14/8. Flip the second, so that'd be 4 over 1. Change the sign. Cross cancel where you can. Okay, 4 and 8 share 4 in common, so this will become 1 and this will become 2. Okay, remember with cross canceling, a cross is good, but as long as it's something on top and something on bottom, you can cross cancel as well. See how I have a 14 and a 2, one on top, one on bottom? I can do it here as well. So 2 goes into 2 one time, 2 goes into 14 7 times. Okay, I have nothing else on top or bottom. I just can't cross cancel straight across. So 7 times 1 is 7. 1 times 1 is 1. In other words, what does that mean? That's the number of loaves. She can make 7 loaves of bread. I answered my final question correctly. Now we can go back and check our answers. If I do 7 times 4, because that's the opposite of dividing by 1/4. Or, never mind, we could plug it back in and see if it works. But for time, I'm going to move to the next part. Okay, go to the next page. Okay, these ones, it says, use the triangle graphic organizer to set up a basic equation for each story problem. All we're doing is setting up the equation. We're not solving. So I know this looks like a lot of stuff, but we're just going to read through it and set up the problem. We're not doing the math. You guys already know how to do the math, but you're struggling with story problems. Okay, a shipment of 14 tons of sugar is separated into containers of equal size. If the shipment fills 5 and 5/6 containers, how much sugar can one container hold? Okay, clue words. How much sugar can one container hold? That's what we're looking for. So one container, would that be the size of groups or the number of groups? Okay, how much is in one container? That would be the size of a group. So I don't know the size of the group. Up here, a shipment of 14 tons of sugar is separated. Ooh, there's a clue word. There's a clue word that we're dividing. So this is being divided. That tells me that's my total. So 14 is a total. We don't know the size of each container, but we know it can fill 5 and 5/6 containers. That's how many containers. So there is my number of groups. So that means I'm going to be dividing the total by the other known number, which is how many groups we can make. there would be your problem. 14 divided into groups of 5 and 5, 6. Okay, let's pick out the context and do that on this one. So, a shipment of sugar fills 2 4/5 containers. If each container, okay, each is a clue word for the size of a group, because each group, size of each group, right? So I'm going to put this down here. I already know that the size of each group is 3 2/7 tons of sugar. What is the amount of sugar in the entire shipment? Entire is a total word. So it's asking what is the entire, so that tells me I'm looking for a total. I know the size of each group right here. The whole shipment fills 2 4/5 containers. That's the size, or that's the number of groups. So what am I going to be doing to figure this one out, to find the total? I'm going to be timesing. So 2 4/5 times 3 2/7 would work. But do you see how we're analyzing each word in the problem to know how we're going to use it? Okay, a construction crew has just finished building a road. The road is 8 kilometers long. If the crew works for 3 1/3 days, how many kilometers of road did they build each day? Okay, there's a clue word, each. That signifies the size of each group. Now, what do we know about the size of each group? We want to find it. How many kilometers each day? So that's the thing I don't know. Okay, let's pick out what we do know. The road is 8 kilometers long. Does that sound like a total, or is that the number of groups? That's the entire road, so that would be a total. So I'm going to put 8 there. The crew worked for 3 1/3 days. Each day is a group of what they worked. So there's my number of groups, 3 1/3. So how would I solve this? The two numbers I do know, division is how they're related. So this would be 8 divided into groups of 3 1/3 to figure out how much they were able to work each day. Okay, a bookstore had 120 copies of a magazine. Yesterday, the bookstore sold 5/6 of them. Of is a times word. So I know that 5/6 is going to be something that is being times. Now, of what? Of these copies. What copies are they referencing? These up here. So if we're timesing 5/6 by something, 5/6 is the number of groups. It wasn't the entire group that they had. So I am going to put 5/6 here. Remember, the number of groups can be just a fraction of a group, and that's what they're referencing here. Of means I'm timesing. Of these copies, what was these copies? 120. So there were 120 in the group. The bookstore had that many copies. We are looking for the total copies sold yesterday. So how would we do this? 5/6 times 120. Alright, a road crew must repave a road that is 7/8 miles long. They can repave 156 miles each hour. How long will it take the crew to repave the road? Okay, total, size of the group, number of groups. They must repave a road that is 7/8 miles long. Okay, that's the entire road, so that tells me it's a total. 7/8 of a mile. They can repave 156 mile each hour. Okay, each clue word for size of groups. So 156 each hour. Now I want to know how long it will take, so I want to know the number of groups, which in this case is hours. So to do that, these are related by division. So 7/8 divided into how much they can do each hour. Alright, a construction crew has just finished building a road. The crew worked for 2 1/5 days. If they built 3 4/7 kilometers of road each day, there's a clue. What is the total length, okay, of the road they built? So what total? what is my clue? That's the thing I don't know. And it says specifically right there, what is a total? So that tells me we're going to know these two. Now let's just decide which is which. The crew worked for 2 1/5 days. They built 3 4/7 kilometers road each day. So if it was each day, that is the size of a group. The size of each group. And 2 1/5 is the number of groups, the number of days they worked. So those are 2 1/5 times 3 4/7. Alright, last part here says, now write a word problem that could be represented by the expression 5 1/3 divided by 2 2/5. You need to write your own story problem to go with this. I'm just going to pick out clues. Don't write exactly what I do. I know that this is division, so what does that tell you about this right here? This is always the total if it's a division. So, write a story problem that has a total of 5 1/3 of something. And then it needs to be being divided into groups of 2 2/5. So, you give me a story problem. If that's all you write, I'm not going to give you credit. So make sure you write me a story problem. It can be about anything that can have fractional amounts. So, rate yourself on this concept. Are you a 0, 1, 2, 3, or 4? Take a picture and turn it in on your passport on Google Classroom.